You are not standing on a stable world. You are on a planet that is constantly in motion, even when nothing around you feels like it is. The ground beneath you is rotating. The planet is orbiting a star at thousands of kilometers per hour, and the entire system is drifting through space in complete silence. But none of this motion is visible, because on this scale, motion disappears, and what remains is the illusion of stillness. If you could remove everything familiar from your perception, you would realize something unsettling. You have never been still, not even for a single second. Somewhere in the darkness beyond our solar system, there are worlds unlike anything close to Earth. Planets where the surface never fully cools. Worlds where oceans are not made of water, but of molten rock moving slowly beneath dark skies. There are places where wind moves faster than sound, and planets where night does not arrive in the way we understand it, but lasts for centuries. Farther out still, beyond the warmth of any nearby star, there are planets drifting alone through interstellar space. No sunrise, no day, only endless darkness, interrupted only by faint, distant light. Most of the universe are not like Earth. Earth feels stable because change happens slowly enough to be familiar. Oceans remain liquid for billions of years. Atmospheres shift gently. Day and night follow each other in steady rhythm. But elsewhere in the universe, this balance is different. Some planets orbit their stars so close that one side remains permanently exposed to light, while the other stays in endless night. Some worlds are locked beneath storms larger than entire planets. Some experience rain made not of water, but of molten minerals. And some drift so far from any star, the heat itself becomes something rare. In these environments, extreme conditions are not exceptions. They are simply different expressions of the same physics. Because over the last few decades, astronomers have discovered thousands of planets beyond our solar system, and slowly a pattern began to appear. The universe does not seem designed around familiarity. It produces variation, massive variation, all shaped by the same slow forces: gravity, heat, pressure, time. And nothing in this process happens quickly. Even the most violent worlds are shaped gradually over millions or billions of years. A planet may spend millions of years migrating inward toward its star. An atmosphere may slowly thicken over immense stretches of time. A storm may continue for centuries simply because nothing exists to stop it. Again and again, the same quiet forces continue their work. Gravity pulls inward. Heat moves outward. Rotation shapes weather. Light crosses empty distance. The motion never fully stops. And somewhere within those distant systems, there are planets unlike anything early human imagination could have predicted. For most of history, humanity knew only the planets visible in the night sky: Mercury, Venus, Mars, Jupiter, Saturn. Slow-moving lights crossing the darkness with predictable rhythm. Later came Uranus, then Neptune, and for a long time it was easy to assume that planetary systems elsewhere might look similar to our own. Small rocky worlds closer to the star,
gas giants farther away, stable orbits, moderate temperatures, a familiar cosmic order. But the universe turned out to be quieter and stranger than expected. Many of the first exoplanets ever discovered were enormous gas giants orbiting impossibly close to their stars. Some completed an orbit in only a few days. These worlds became known as hot Jupiters, and they changed everything. Because such planets should not have formed there. Near a young star, temperatures are often too high for giant planets to emerge easily, which meant those planets likely formed much farther away and slowly drifted inward over time. An entire world migrating through its solar system, not suddenly, not violently, but gradually, pulled by gravity through long interactions with gas, dust, and neighboring planets. Over millions of years, the orbit changes, the distance shrinks, the skies grow brighter, the atmosphere becomes hotter, until eventually a giant world settles into an orbit so close to its star that its outer atmosphere begins to expand into space itself. On some of these worlds, temperatures rise beyond 1,000 degrees. Clouds cannot form from water there. Instead, the atmosphere may contain vaporized metals, iron, magnesium, silicates. The familiar chemistry of Earth no longer behaves in familiar ways. Rock becomes fluid, minerals evaporate into the air, and still the planet continues its orbit again and again, endlessly repeating the same path around its star. One of these worlds is known as 55 Cancri E, a rocky planet larger than Earth, orbiting so close to its parent star that a full year lasts less than a single Earth day. The surface temperature may be hot enough to melt large regions of stone. On the daylight side, the ground itself could behave almost like an ocean, not water, but molten rock moving slowly beneath a glowing horizon. And because the planet is likely tidally locked, one side always faces the star, the same hemisphere receiving constant heat, the same landscape remaining in permanent daylight, while the opposite side exists in endless darkness. No sunrise, no sunset, only two vast hemispheres divided by temperature and light.
This pattern appears often in the universe, especially around smaller stars. Over time, gravity synchronizes the planet's rotation with its orbit. The process is slow, but persistent. Eventually, the world rotates exactly once for every orbit around its star. And after enough time passes, one side never turns away again. On Earth, rotation constantly redistributes warmth. The atmosphere moves heat around the globe. The oceans circulate energy slowly. Day and night alternate with steady rhythm. But on tidally locked planets, the balance becomes far more extreme. The star-facing side may remain blisteringly hot. The dark side may freeze beneath permanent night. Between them, there could exist a narrow band of endless twilight, neither true day nor true night. Perhaps strong winds move continuously between the two hemispheres, hot air rising beneath eternal sunlight, cold air sinking in darkness. The atmosphere itself becoming a slow planetary circulation system that never stops. No mornings arrive there, no evenings,
only continuous motion repeating across immense stretches of time. And yet, even these strange worlds are not the most isolated planets the universe may contain. In many ways, planets are shaped less by what they are and more by where they are. Distance changes everything. A small shift inward toward a star can transform ice into ocean. A little closer still, and oceans become vapor. Closer again, and even stone begins to soften beneath constant heat. Farther away, motion slows. Light weakens. Atmospheres freeze quietly onto the ground. The universe does not divide worlds into simple categories. Instead, each planet exists somewhere along a gradual spectrum shaped by temperature, gravity, pressure, and time. And among the strangest of these worlds are the giant planets where weather itself becomes planetary in scale. In our own solar system, Jupiter already offers a quiet example of this. Beneath its pale bands of cloud, storms rotate continuously through the upper atmosphere. Some have lasted for centuries. The great red spot, slowly turning in the southern hemisphere, is larger than Earth itself. And even there, within the familiar structure of our solar system, winds can move at extraordinary speeds. But beyond our system, astronomers have found worlds where atmospheric motion becomes even more extreme. Some giant planets orbit so close to their stars that the upper atmosphere receives enormous energy every second. The heating is uneven. One side faces the star continuously. The other remains darker and cooler. And because of this imbalance, the atmosphere begins transporting heat across the planet through immense circulating winds. On certain hot gas giants, these winds may travel thousands of kilometers per hour, jet streams moving continuously around the equator. Not temporary storms, not seasonal weather, but stable atmospheric systems repeating their motion again and again.
The sky there would not resemble Earth's sky. There may be no blue horizon, no drifting white clouds, no rainfall in any familiar form. Instead, layers of heated gas stretch upward into deep atmospheric darkness. Clouds may form from silicates or vaporized metals. At certain temperatures, even iron can exist as part of the atmosphere itself. And somewhere high above the deeper layers, tiny mineral particles may slowly condense and fall. On Earth, rain softens landscapes over long periods of time. On some distant worlds, the rain may be made of molten glass. Winds carrying sharp mineral particles sideways through the atmosphere at enormous speeds. Yet even these environments are governed by the same quiet physical laws. Heat rises, pressure shifts, rotation bends atmospheric motion into stable patterns. Again and again, the system repeats. And beneath the storms, beneath the cloud layers, beneath immense pressure, gravity continues pulling inward with calm persistence. Gravity changes a planet slowly. On larger rocky worlds known as super-Earths, its influence becomes impossible to ignore. These planets are more massive than Earth, but still composed primarily of rock and metal. Some may possess thick atmospheres. Some may possess deep oceans. Others could be dry worlds with immense mountain ranges slowly collapsing under their own weight. A person standing on such a planet would feel it immediately. Movement becomes heavier, each step requiring more effort. The atmosphere feels denser, clouds lower, rain heavier, even the shape of the landscape begins to change. Tall mountains cannot survive forever here. Rock slowly collapses inward under its own weight. Cliffs soften, peaks broaden. The planet reshapes itself, not through sudden events, but through pressure alone. Only time is required. Time and gravity. Together, they transform entire worlds. This process unfolds quietly across billions of years. Tectonic plates drift, volcanoes release gases, impacts reshape surfaces, erosion smooths sharp edges. A planet is never fully still. Even when it appears silent from space, it is changing beneath its surface. And some worlds experience this internal motion even more intensely. There are planets where volcanic activity dominates the entire surface, not because of the star alone, but because of gravity itself. In our solar system, one clear example is Io, a moon orbiting Jupiter. As it moves through Jupiter's immense gravitational field, the interior is constantly stretched and compressed, very slightly, but continuously. Rock flexes again and again, and over time, friction inside the interior generates extreme heat. Volcanoes erupt across the surface. Sulfur spreads in yellow, orange, and black. The surface is never stable. Not because of weather, not because of oceans, but because gravity itself is constantly reshaping it from within.
Elsewhere in the galaxy, similar forces may act on even larger scales. Entire surfaces shaped by tidal heating, molten regions glowing faintly beneath dark skies, lava flows cooling slowly under alien atmospheres. On such worlds, night is not fully dark. Light from volcanic activity moves across the horizon in distant pulses, a slow rhythm of brightness within an otherwise silent landscape. And even extreme heat eventually becomes part of a cycle. Chaos settles into rhythm. Storms become systems. Volcanoes become cycles. Orbits repeat. Temperatures stabilize. Over long enough time, even violent environments find balance. And sometimes that balance produces stillness. Far from the warmth of stars, frozen planets exist in near silence. At extreme distances, sunlight becomes faint and weak. The sky darkens. Temperatures fall. Atmospheric gases freeze onto the surface. Nitrogen becomes ice. Methane condenses. Oceans, if they exist, are sealed beneath frozen crust. And yet, cold does not stop motion completely. Ice still shifts. Glaciers still flow slowly. A frozen world can change for millions of years without producing a single sound. Cracks spread gradually. Subsurface oceans push upward. Frost drifts down through thin air. Everything slows, but almost nothing fully stops. And under weak starlight, these distant planets may appear peaceful, a quiet sphere suspended in darkness, orbiting endlessly through cold regions where time itself feels softer. Because in places where change happens slowly, the mind begins to experience time differently. A single orbit can last centuries. A season may stretch longer than entire human civilizations. Cloud systems form slowly above distant atmospheres, staying in motion long after any observer capable of noticing them has disappeared. The universe does not rush its structures. It builds them through repetition, through cycles, through motion so gradual that it becomes almost invisible unless you look across immense spans of time. And this is why distant worlds, even extreme ones, can feel strangely calm when imagined in this way. Not because they are peaceful, but because everything there is slow enough to resemble stillness. Even the most unusual planets are governed by repetition, predictable motion unfolding in darkness, gravity pulling inward, heat moving outward, rotation continuing without interruption. Among the more complex environments discovered by astronomers are planets that orbit more than one star. In these systems, gravity is no longer simple. Two stars move around each other, locked in mutual orbit, while a planet circles both of them at once.
If we zoom out far enough, even the idea of a planet begins to feel less like an object and more like a temporary phase inside a much larger process. A planet is not something that simply exists and stays the same. It is something that is constantly being shaped by everything around it. By gravity pulling inward, by heat moving outward, by collisions that happened long before the planet fully formed, by radiation arriving from a star that itself is slowly changing. Nothing about a planet is isolated. Even its surface is not truly separate from its interior. Rock slowly flows over geological time. Heat rises from deep layers. Magnetic fields are generated by motion hidden far beneath the crust. What looks like a solid, stable world is actually a slow system of movement held together by balance. And that balance is never permanent. It only lasts as long as the surrounding conditions allow it to last. A small change in orbit can shift everything. A slight increase in stellar brightness can begin to evaporate oceans. A gradual cooling inside the planet can silence volcanic activity forever. But none of these changes happen in a moment. They unfold across scales so large that they disappear from everyday perception, which is why planets can appear stable even when they are not. From the outside, a world may look unchanged for millions of years, but inside that same time, it may pass through entirely different states of existence. A molten beginning, a temperate middle, a frozen ending, or the reverse, or something entirely different that does not fit Earth's sequence at all. Because there is no single normal path for a planet. There are only trajectories shaped by initial conditions and long-term physics, and those trajectories can drift slowly into very different outcomes. Some worlds grow closer to their stars over time. Others are pushed outward. Some lose their atmospheres entirely. Some gain them later from volcanic outgassing or comet impacts. Some are destroyed in collisions that happened so slowly from a cosmic perspective that they feel almost inevitable rather than sudden. Even destruction in space is not an instant event most of the time. It is often the result of long instability building quietly until balance can no longer hold. And even then, the material does not disappear. It spreads, it reforms, it becomes part of something new. That is one of the quiet rules of the universe. Nothing is truly erased, only redistributed. A planet that no longer exists as a planet may still exist as dust, debris, rings or fragments orbiting a star in a new configuration.
And over time, even that material can become part of another system, another disk, another planet, another cycle. This is why planetary history is never truly finished. It is continuous transformation layered over transformation. Older systems influencing newer ones, newer systems reshaping older remnants. All of it occurring at speeds too slow for direct observation. Which is why astronomy often feels like reading something that is still being written. We are not looking at completed stories. We are looking at ongoing processes. Light that left planets long ago. Signals that carry information across distances too large for immediacy. Patterns that only make sense when time is included as part of what we are observing. And when time is included, everything becomes less sudden. Even extreme environments lose their sense of abruptness. A molten world is not burning, it is balancing heat over time. A frozen rogue planet is not dead, it is slowly losing energy into space. A gas giant storm is not violent, it is a stable circulation pattern maintained by continuous energy flow. Everything becomes process instead of event. And once you start seeing planets this way, even the most dramatic descriptions begin to soften, because there is always a longer timeline behind them, always a slower rhythm underneath them, always a deeper layer of continuity holding everything together. Gravity does not turn on and off. Heat does not jump randomly. Orbits do not reset. Atmospheres do not appear suddenly fully formed. Everything accumulates. Everything evolves. Everything persists in motion. And so the universe never feels like a collection of separate things anymore. It begins to feel like a single unfolding system expressing itself in many forms at once. Planets are just one of those forms, temporary, varied, and constantly shifting, but never separate from the rest of it, always part of the same quiet expansion of structure across time. And even as we think about this for a moment longer, nothing in that system ever pauses. It only continues, slowly, continuously, without interruption.
The sky on such a world would never behave in a fully familiar way. Light would shift in layered patterns across the atmosphere. Sometimes one sun would rise alone. Sometimes both would hang above the horizon together. At other times, one star might pass in front of the other, slowly dimming the entire landscape. Shadows would not feel stable there. They would stretch and overlap across longer cycles of time, repeating patterns that only make sense when seen across years rather than hours. And yet, even here, stability eventually emerges. Orbits settle. Motion becomes predictable again. Because whenever balance is possible, the universe tends toward it, not quickly, but persistently. This principle does not apply only to planets, but to the stars that form them. Young planetary systems begin as dense, rotating disks of gas and dust surrounding newborn stars. At first, everything is small and chaotic at the microscopic level. Particles collide gently, stick together, separate, collide again. A grain of dust drifting through this disk seems insignificant, but over time, those tiny interactions accumulate. Dust becomes pebble, pebble becomes rock, rock becomes planetesimal, planetesimal becomes a world. Nothing in this process happens quickly. It is built from repetition stretched across millions of years. And because each system evolves under slightly different conditions, no two planetary systems become identical. Some planets migrate inward, some are pushed outward, Some collide and merge into larger bodies. Some are ejected entirely from their systems before they ever fully stabilize. The final architecture of a planetary system is the result of countless small gravitational interactions, repeated endlessly until a structure remains. And in some of these systems, planets orbit close enough that they dominate each other's skies. A neighboring planet may appear not as a point of light, but as a visible world suspended above the horizon, cloud bands slowly rotating, sunlight reflecting across curved atmospheres, a crescent shape hanging motionless from a human perspective, yet still quietly moving through space. In certain cases, a gas giant may remain fixed in the sky, appearing almost stationary while everything else shifts around it. This creates a strange contradiction: stillness that is not still, motion too slow to perceive. And this illusion repeats throughout the cosmos. Galaxies rotate, stars orbit galactic centers, planets orbit stars, moons orbit planets. Nothing is truly stationary, but much of this motion unfolds so slowly that it resembles permanence. Nowhere is this illusion stronger than on tidally locked worlds. On these planets, one side always faces the star, the other remains in eternal night. On the dark hemisphere, the sky may never brighten. No sunrise, no sunset, only a constant frozen night stretching across geological time.
The surface there could remain locked in cold for millions or even billions of years. Ice spreading slowly across landscapes, atmospheres condensing and settling into frost. A stillness that is only apparent because beneath the surface, motion continues. Heat from the interior rises gradually. Tides may shift hidden oceans beneath thick ice layers. Energy moves through the planet in ways that are not immediately visible. Even in permanent darkness, the planet is not truly inactive. It is only moving too slowly for direct perception. If life ever existed in such environments, its sense of time would likely differ completely from surface life under a bright star. Changes would be subtle, measured in temperature shifts, pressure variations, slow chemical gradients beneath ice and water. The universe allows for environments that feel almost impossible to imagine, and yet every one of them follows the same underlying rules: gravity, heat, matter, time. Only the arrangement changes. Some planets may contain oceans far deeper than anything on Earth. A world covered entirely with water would have no continents at all, only a global ocean stretching in every direction beneath clouded skies. Storms would travel across uninterrupted water for thousands of kilometers. Currents would circulate continuously through immense depths. Pressure would increase steadily as you moved downward. At extreme depths, water itself begins to behave differently. Under immense pressure, exotic high-density ice structures can form beneath the ocean, even while liquid water exists above them. The chemistry of such a planet would be shaped entirely by depth and pressure, heat distribution, nutrient flow, atmospheric interaction with a single continuous ocean surface. And still, the planet would rotate. Still, it would orbit its star. Clouds would form, rain would fall, currents would move, again and again, without interruption. Across all planetary environments, one pattern remains constant. Motion repeats. Rotation, orbit, circulation, balance.
Even when conditions become extreme, the system remains structured by the same fundamental principles. And yet, planets are not permanent. Some orbit so close to their stars that their atmospheres slowly escape into space. Heated continuously at the upper layers, particles gain enough energy to drift away from the planet entirely. Over millions of years, the atmosphere thins. The world slowly loses part of itself into surrounding space. Astronomers have observed planets surrounded by vast, trailing clouds of escaping gas, stretched behind them like fading remnants. These are not sudden transformations, they are slow dissolutions, endings that unfold over immense spans of time. Because in the universe, even endings tend to be gradual. Planets evolve, they cool, they migrate, they erode, they lose atmospheres, they change form, and eventually some may disappear completely into their stars, but almost never quickly. The universe prefers long transitions.
Even destruction usually unfolds with patience. A star does not change abruptly. It evolves slowly over immense stretches of time, gradually increasing its energy output as it ages. Nearby planets do not react in a single moment. They respond across long, quiet intervals where nothing feels immediate, but everything is shifting underneath. Ice begins to melt, not suddenly, but through a persistent rise in heat. Atmospheres adjust molecule by molecule. Oceans thin out, slowly releasing vapor into the sky. What might look like transformation from a distance is, locally, almost unnoticeable. There is no clear breaking point, only continuous physical processes unfolding so gradually that no single moment feels catastrophic. And because change is so slow, planets rarely remain in one state for their entire existence. A frozen world may once have carried liquid oceans. A temperate planet may eventually dry out, its surface becoming silent and rigid. Gas giants may drift inward through their systems across millions or even billions of years. Nothing in the cosmos is permanently fixed. Even stability is only long-term relative calm. And yet, temporary, in cosmic terms, can still mean billions of years. There are planets older than Earth itself, worlds that formed when the galaxy was in a very different stage of its evolution. Ancient planets orbiting ancient stars in regions where motion has continued in near silence for timescales that are difficult to imagine from a human perspective. If you stood beneath the sky of one of these old worlds, the experience might still feel familiar at first glance. Stars above, a horizon below, a sense of space surrounding everything. But the details would be different. Subtly unfamiliar constellations, slightly altered stellar patterns, light that has been traveling for longer than entire species have existed. Yet beneath that difference, the same deep structure remains. A planet turning under gravity, clouds drifting through atmosphere, light crossing enormous distances. Age changes the character of a world in quiet ways. Over time, internal heat fades. Radioactive elements within a planet's core release less energy. Volcanic activity slows, tectonic movement weakens, magnetic fields may fade or disappear entirely. The surface becomes quieter, not empty, just less dynamic. Craters remain preserved for longer periods, mountains erode more slowly,
Dust accumulates across ancient terrain under thin, distant light. Some planets spend billions of years moving gradually toward geological stillness, and even then, orbital motion continues without interruption. The planet still circles its star. One year follows another. The pattern repeats in perfect consistency across deep time.
Among the quietest environments in the universe are likely the cold gas giants orbiting far from their stars. At extreme distances, sunlight becomes so weak that even daytime resembles a permanent twilight. The upper atmosphere may appear pale, softly illuminated by distant light that carries little warmth. Deeper down, pressure increases steadily. Hydrogen transitions slowly into denser states. Layer after layer descends into darker and more compressed regions where familiar concepts of surface begin to lose meaning. On gas giants, there may be no solid ground at all, only a continuous transition from atmosphere into fluid-like layers beneath. Cloud bands still exist, storm systems still form, but from a distance, these planets often appear calm, smooth spheres with faint horizontal striping, atmospheric motion continuing quietly across enormous scales. And around many of these giants, moons orbit in complex but stable systems. Frozen worlds, rocky worlds, bodies with hidden subsurface oceans, each one circling a larger planet in repeating gravitational cycles that can persist for billions of years. The outer regions of planetary systems are environments defined by distance and reduction. Less light, less energy, slower change. Orbital periods stretch longer. Temperatures fall lower. Physical processes unfold more gradually. Even sunlight feels different there, not in nature, but in arrival, a reminder that light itself requires time to travel. On Earth, sunlight arrives in minutes, but farther out in a system, it takes hours. Beyond that, it becomes weaker still, stretched across vast distances into a faint and distant illumination. Yet even in these outer regions, structure remains. Dust forms rings. Moons hold stable orbits. Comets travel along elongated paths that can take thousands of years to complete. Activity does not stop, it simply slows. There are worlds where a single season lasts for decades. On such planets, axial tilt or orbital distance creates climate cycles that unfold at extreme pace scales. A hemisphere may drift toward darkness over many years. Temperatures drop gradually. Ice spreads slowly across landscapes. Then, after long silence, light returns. Not suddenly, but as a slow re-emergence that can last just as long. Winds shift, atmospheres respond, frozen gases re-enter circulation. These are not weather events in the familiar sense. They are planetary-scale climate transitions unfolding across lifetimes that far exceed anything experienced on Earth. Human perception is built around short cycles, days, weeks, years, but planetary systems operate on vastly larger rhythms. And when those rhythms are considered, something subtle changes in perspective. Urgency begins to fade, because the universe does not behave urgently. Stars burn slowly, galaxies rotate slowly, planets cool slowly.
Light itself crosses space over long intervals that turn distance into time.
Some of the worlds observed in the night sky may already have changed by the time their light reaches us. We are not seeing them as they are now, but as they were when that light first began its journey. The night sky is therefore not a static image. It is a layered record of different moments arriving from different distances, a quiet timeline stretched across space. And within that distant light, there may be countless worlds unlike anything yet fully understood. Planets orbiting dead stars, frozen worlds drifting between systems, rocky planets illuminated by faint red dwarfs that never brighten into familiar daylight, atmospheres denser than oceans, systems still forming, systems slowly dissolving. Variation is not rare in the universe. It is the default outcome of its physical laws. Gravity gathers matter, heat redistributes energy, motion continues. Small differences in initial conditions produce entirely different worlds over time. A shift in mass, a shift in distance, a shift in composition, each one leading to a different planetary outcome. Yet all of them remain within the same framework. Hydrogen still fuses in stars, gravity still shapes motion, heat still flows outward, time still moves forward. Even among extreme worlds, the underlying consistency is striking. Nothing remains random for long. Patterns emerge, systems stabilize, motion organizes itself into predictable cycles. A planet may begin in chaos, but over time it often settles into balance simply because stable configurations persist longer than unstable ones. And across the galaxy, countless worlds continue their slow existence within this structure. Some under permanent daylight, some under endless night, some wrapped in storms, some covered in oceans, some wandering alone through interstellar space, all of them turning, all of them orbiting, all of them changing, almost imperceptibly across immense spans of time. And eventually, as all of this is held in mind a little longer, the idea of extreme begins to dissolve into something quieter. Not because these worlds become less unusual, but because the distance between them and everything else shrinks inside understanding. A lava-covered planet, a frozen rogue world drifting alone in darkness, a gas giant wrapped in endless storms. They no longer feel like separate categories of existence. They begin to feel like different expressions of the same long process. Matter gathering, energy flowing, gravity shaping structure, time allowing everything to slowly settle into form. There is no sharp boundary where one kind of world ends and another begins, only gradual transitions, a continuous spectrum of conditions stretching across space, and every point on that spectrum is temporary.
A planet is never truly finished. It is always in the middle of becoming something else, cooling, heating, migrating, eroding, accreting, changing orbit, losing atmosphere, gaining new layers of structure, slowly adjusting to whatever forces surround it. Even when nothing appears to happen, change continues beneath the surface. Deep within rock, within air, within ice, within gravity itself. And over long enough timescales, even the most stable systems begin to drift into new configurations. Stars evolve, orbits shift,
Atmospheres escape, moons separate, rings form and dissolve, but none of it happens quickly. The universe does not reset. It transforms, quietly, continuously, without a clear beginning and without a final end. And so, as this journey through extreme planets gently settles, there is nothing that truly concludes. No final state to reach, no final image to hold, only motion continuing across vast distances. Planets still orbiting their stars, stars still moving through galaxies, galaxies still drifting through expanding space, and space itself still unfolding slowly across time that has no visible edge. Everything remains in motion, everything remains connected, and everything continues, quietly, beyond the reach of any single moment.